Welcome to this new activity, which is an application to economics of the optimization procedure. So the marketing research department of a computer company used a large city to test market the firm's new laptop. The department found that the relationship between price P in dollars per unit and the demand X units per week was given approximately by P equals 1,296 minus 0.12 X squared for X between 0 and 80. The question is, find the local extrema for the revenue function. So first of all, let's compute the revenue function. So R of X is equal to X times P, the quantity times the price, okay? So it's equal to X times 1,296 minus 0.12 X squared, which is equal to 1,296X minus 0.12 X cubed. So this is the revenue function, R of X. Now, to find the local extrema of the revenue function, we need to find the critical points. So first of all, compute R prime of X, which is equal to 1,296 minus 0.36 X squared. We use the power rule here. 3 times 0.12 is equal to 0.36, and we decrease the power of X by 1, so X squared. Now, we solve R prime of X equals 0, which means that X squared equals 1,296 over 0.36, which is equal to 3,600. Now, what are the solutions for X? Here, we're going to find X equals negative 60 or X equals 60, the square root of 3,600. Now, remember that we are dealing with an application to economics, so the X is a quantity, it's greater than 0, and here we have the interval 0,80. The domain of this revenue function will be 0,80, so the X equals negative 60 must be excluded here, okay? We keep only the positive solution, and we check that it's in the domain of the function, so it's X equals 60. Now, let's check if there is a point where R of X is defined and R prime of X is not defined. No, because both are polynomial functions, so they are defined everywhere. So the only critical point is X equals 60, okay? Now, we're gonna check that at this point we have a local extrema. So we're gonna make the sign chart, okay? We're gonna draw the sign chart here and check that we have a local extrema there, okay? The sign chart will start at 0 because our domain is 0, 80, so we're gonna stop at 80, okay? We put our critical point, which is X equals 60, around here, let's say, okay? R prime of X is equal to 0 there. So R prime of X is equal to 0 at 60, okay? Now we check the sign of R prime of X over the interval 0, 60. For example, we can take a test point, for example 1, X equals 1. We check here 1,296 minus 0.36 times 1 squared, which is obviously positive. We take a test point on 60, 80, for example, 70. You substitute your X by 70 in the expression of R prime, and you check that it's a negative value. So R prime of X will be negative here. So what's about R? It will be increasing here, and then it's decreasing. So we can see clearly that we have a local maximum at X equals 60. And the question is, find the local extrema. So we identified our local. We have a local maximum at X equals 60. 60 what? 60 laptops, since it's the number of laptops, okay? So this is the only extremum for this function. So we answered to the question. Thank you for your attention and see you in the next videos.